So this time we're revolving the graph of y equals x squared on the interval 0 to square root of pi over 2. So let's actually start writing down some of this information. So we've been given y equals f of x, right? So f of x is equal to x squared. And we are told on the interval 0 to root 2. So that means x is in between 0 and root 2. And we're supposed to revolve it about the y-axis. So the formula that we'll need is S is equal to, surface area is equal to the integral from a to b, 2 pi x square root 1 plus f prime of x.
It's 1615.
Quantity squared dx. So a is equal to 0, b is equal to square root of 2. And looking at our picture here, we want to, let's see here, so this is -1, and over here is -2. So I stopped at what I thought was square root of 2. I approximated square root of 2 is about 1.4. Okay, so when we draw this, we should get something like this. Okay, so this is our three-dimensional surface here. Kind of get an idea. And we want the area of this surface. So this is our goal, is to find the area of this surface. So we have our formula. So let's go ahead and start computing. So we'll have our surface area equals the integral from a to b, 2 pi x times square root of 1 plus f prime of x quantity squared dx. Okay, and we said that a is equal to 0 and b is equal to square root of 2. Now we have 2 pi x times the square root of 1 plus, I forgot, I need to compute f prime of x. F prime of x, if f of x is equal to x squared, f prime of x is just going to be 2x. Okay, so here I am down in my formula, right, and I need that square root of 1 plus f prime of x squared. So we're 1 plus quantity 2x squared dx. So we should get that this is equal to the integral from 0 to square root of 2 pi x square root 1 plus 4x squared dx. Now, let's see here. So we'll go over here to the right-hand side and see if we can evaluate this integral of x square root 1 plus 4x squared dx. So I'm going to do a u substitution. So I'm going to let u equal 1 plus 4x squared. And then du is equal to 8x dx. So I can rewrite this integral as 1/8 integral of square root of u du. So I'll get u to the 3/2 over 3/2. And all this is multiplied by 1/8. And let's see here. So times 2/3 times 2/3. And we'll have, that'll turn to a 4. So we should have 1 over 12. 1 over 12 u to the 3/2. But remember, u is 1 plus 4x squared. So we should have 1/12, 1 plus 4x squared quantity to the 3/2. Okay. So evaluating this, we're going to get this is equal to 2 pi. We can bring the 2 pi out front. Times 1/12. Okay, and then 1 plus 4x squared plus 4x squared to the 3/2 evaluated x equals 0, x equals root 2. Okay, let's see here. Equals, so we'll have that 2 pi over 12 times 1 plus 4 times the square root of 2 squared, all of that to the 3/2, minus 1 plus 4 times 0 squared to the 3/2. Okay? So I'm just evaluating my antiderivative at the endpoints. Let's simplify the 2 and the 12, so I get pi over 6. Okay? Now square root of 2 squared should give me, that should just be 2. So it should be 4 times 2 plus 1, which would be 9. Right? And now 9 to the 3/2 means I need the square root of 9 cubed. Right? So that's equal to the square root of 9 cubed, which is going to be 3 cubed, which is going to be 27. Okay. So I'll have equals pi over 6 times 27 minus over here I should just have 1 because that's going to be 0, and so this inside part here is going to be 1, and when I take the square root of 1 I'll get 1, and when I cube it I'll get 1, so it should just be minus 1, so I'll get 26 pi over 6, which is 13 pi over 3. And so that is my final answer.